Yes, friends, let us see exercise 8.2. Question number 1. You are having textbooks now? Yes. See in your textbook. Evaluate the following. It has got 5 parts, right? Let us see first part. Sin 60 degrees multiplied by cos 30 degrees plus sin 30 degrees multiplied by cos 60 degrees. An expression is given, you are supposed to find the value of this expression. Anyway, you are familiar with this now? Table. Basics already you are familiar with them, I think, right? This is right angle triangle. This is Pythagoras theorem. There are 6 trigonometric ratios: sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. Sin theta is opposite by hypotenuse or perpendicular by hypotenuse. Cos theta is adjacent side by hypotenuse or base by hypotenuse. Tan theta is opposite by adjacent side or perpendicular by base. Anyway, this trigonometric ratio cosecant theta is reciprocal of sin theta, secant theta is reciprocal of cos theta, cot theta is reciprocal of tan theta. Again, one more relation we can observe is sin theta by cos theta is tan theta, cos theta by sin theta is cot theta. This is anyway for some specific angles we have found out trigonometric ratios, values of these 60 trigonometric ratios, and we have tabulated them. This is the table. You are supposed to remember this table, right? What are those specific angles? 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. For these 5 angles, all these 6 trigonometric ratio values we have found it and tabulated here. See, how will you remember them? It's not that difficult. This is easy, because if you are new to this, you may feel that this is difficult to remember, but this is easy. See, you simply remember these 3 values. You can write all the remaining ones. Yes. See, sine value, what does it mean? Sine 0 degrees is 0. Sine 30 degrees is 1 by 2. Sine 45 degrees is 1 by root 2. Sine 60 degrees is root 3 by 2. Sine 90 degrees is 1. In the same way, cos 0 degrees is 1. Cos 30 degrees is root 3 by 2. Cos 45 degrees is 1 by root 2. Cos 60 degrees is 1 by 2. Cos 90 degrees is 0. In the same way, tan 0 degrees is 0. Tan 30 degrees is 1 by root 3. Tan 45 degrees is 1. Tan 60 degrees is root 3. Tan 90 degrees is not defined. How will you see this? Tan theta is sin theta by cos theta. This by this is this, right? 0 by 1 is 0. 1 by 2 by root 3 by 2 is 2. Both denominators are equal here. So if you divide, denominators get cancelled. 1 by root 3 will be remaining. This is 1 by root 3. In the same way, because these two are equal, ratio is 1. In the same way, cancel the denominators, you will get root 3 by 1. That is root 3. Here 1 by 0. In a ratio, if denominator is 0, that ratio is not defined. So 1 by 0, so not defined. So tan 90 degrees is not defined. In the same way, how about cosecant here? Cosecant is reciprocal of sine, we know, right? So 1 by sine is cosecant. So 1 by 0, not defined. 1 by 1 by 2, 2. 1 by 1 by root 2, root 2. 1 by root 3 by 2, 2 by root 3. 1 by 1, 1. In the same way, secant A, reciprocal of this. You can observe. In the same way, cot A is reciprocal of this. Yes, cot theta is reciprocal of this, right? Is it not? This is sin theta by cos theta, this is cos theta by sin theta. So cot is reciprocal of tan. So 1 by 0, not defined. 1 by 1 by root 3, root 3. 1 by 1, 1. 1 by this. 1 by, of course, cos by sin, you can see this, see it like this. This by this is 0, right? Anyway, see, I have observed, see, anyway, you also can observe values of sin theta. See, 0 to 1 they are increasing. 0 to 1 increasing. See, 1 by 2 is greater than this. 1 by root 2 is greater than this. 1 root 3 by 2 is greater than this. 1 is greater than this. In the same way, cos values 1 to 0 decreasing. Again, one more observation. If you can remember these 3, see, 1 by 2 came here. Again, this is 1 by root 2 here, root 3 by 2 here. In opposite order you have written. 0 you have written here, 1 you have written here. This one here, this one here, this one here. Right? A reverse order. Don't get confused. Reciprocal is different, reverse order is different. Right? So 0, 1 of course I will remember. Sin A is increasing from 0 to 1. Cos A is decreasing from 1 to 0. Right? If I can remember 1 by 2, 1 by root 2, root 3 by 2, I can say that sin 30 degrees and cos 60 degrees are equal. 1 by 2, 1 by 2. Sin 45 degrees and cos 45 degrees are equal. 1 by root 2, 1 by root 2. Sin 60 degrees and cos 30 degrees are equal. Root 3 by 2, root 3 by 2. Right? Shall we remember? Yes. 1 by 2. Close your eyes and recollect. 1 by 2, 1 by root 2, root 3 by 2. That is 30 degrees, 45 degrees, 60 degrees. Anyway, 0 degrees, 90 degrees are at ends. Now let us recollect values of sin. Sin 0 degrees is 0. Sin 30 degrees is 1 by 2. Sin 45 degrees is 1 by root 2. Sin 60 degrees is root 3 by 2. Sin 90 degrees is 1. How about cos? Cos 0 degrees is 1. Reverse order. Cos 30 degrees is sin 60. Is it not? Cos 30 is sin 60. Sin 60 is root 3 by 2. So cos 30 is also root 3 by 2. I will remember like this. Next, cos 45 degrees. Same as sin 45 degrees. 1 by root 2, 1 by root 2. Next, cos 60 degrees I want. I have remembered that as sin 30 degrees. Both are equal, right? Reverse order. So this is 1 by 2 I know. So this is also 1 by 2. Cos 90 degrees is 0. So if I can remember these values, I can write these values reciprocal. Of course, tan A will be this ratio of sin by cos. So this by this 0 by 1 is 0 and so on. But I will remember tan values also because they are also used in questions in trigonometry frequently. That's why these three ratios values we will remember. Anyway, let us see questions. See question number 1, first part. Tell me what is sin 60 degrees from table? Yes, root 3 by 2 multiplied by cos 30. How have you remembered? Cos 30 is nothing but sin 60. Sin 60, that is again root 3 by 2. Plus sin 30 degrees 1 by 2 from table, again multiplied by cos 60 degrees is sin 30 degrees. Cos 60 is equal to sin 30. Right? Sin 30. Both are same. Yes. That is 1 by 2. So, multiply. Denominators 2 into 2 is 4. Multiply the numerators. Root 3 into root 3. 3. Plus denominators 2 into 2 is 4. Numerators 1 into 1 is 1. So, this is LCM is 4. 3 plus 1 is 4. 4 by 4. That is 1. That is 1. Next. Second part. 2 tan square 45 degrees plus cos square 30 degrees minus sin square 60 degrees. That is the question. See, what is this tan square theta? This is tan theta whole square. Is it not? Yes. Tan square theta is tan theta whole square. Yes. Now tell me, what is tan square 45 degrees? Yes. Tan square 45 degrees is tan 45 degrees whole square. What is tan 45 degrees? See this. Tan 45 degrees is 1. In the same way, you remember this also. Cot 45 degrees. That is reciprocal of tan. So 1 by 1 is again 1. Remember these two. Tan 45 degrees is 1. Cot 45 degrees is also 1. So this is 1 square plus cos 30. That is sin 60. That's how I have remembered. Sin 60 is root 3 by 2 whole square minus this is sin square 60 degrees. That is sin 60 degrees whole square. Sin 60 degrees from table is root 3 by 2 whole square. Yes, let us simplify further. 1 square is 1. 1 into 2 is 2 plus this is root 3 whole square by 2 square. Root 3 whole square is 3. 2 square is 4 minus Of course, you need not do this. See, you can observe that these two are equal, right? Blindly we cannot, need not go like this. If you can observe these two are equal, right, you can cancel. So what will be remaining? 1 square is 1 multiplied by 2. So this is 2. 2 into 1 is 2, right? This is part 3. Next part 3. Yes, cos 45 degrees divided by secant 30 degrees plus cosecant 30 degrees. That is the question. See this. Yes, cos 45 degrees. Let us substitute the value from table. How do you remember cos 45 degrees? Yes, how have you remembered? For 45 degrees, sin and cos are same, right? For 1 by root 2, 1 by root 2. So cos 45 degrees is 1 by root 2 divided by upon secant 30 degrees. What is secant? How do you remember values of secant? Secant A is reciprocal of cos A, right? Secant is reciprocal of cos. Cos, if you can remember, you can write secant values. Of course, cos, how have you remembered? Reverse order of sine, right? Yes, you tell me now. Secant 30 degrees is 1 by cos 30 degrees. Cos 30 degrees is sin 60 degrees, right? Sin 60, cos 30. They are same. I have remembered these three, na? Sin 60 degrees is root 3 by 2. So cos 30 degrees is again same, root 3 by 2. So this is reciprocal of that. So 2 by root 3 plus, in the same way, tell me, cosecant 30 degrees. Of course, from table, cosecant 30 degrees is 2, right? Of course, secant 30 degrees, I have written 2 by root 3. I need not remember these three, right? That's why. Anyway, from table you can write, if you can remember directly, or as I do, you also can try. Cosecant 30, I will think like this. This is reciprocal of sine. So 1 by sin 30. Sin 30 I have remembered. That is 1 by 2. So reciprocal of 1 by 2 is 2. So this is 2 by 1 or 2. Right? So let us simplify further. This is 1 by root 2 divided by, what is LCM here? Root 3. Numerator is 2 plus 2 root 3, right? Of course. So this is, says, how shall we simplify this further? See, this is of the form A by B divided by C by D, right? How can I write? This can be written as A by B multiplied by D by C. Don't get confused, right? If you have A by B whole by C by D, A by B upon C by D, you can write it as A by B multiplied by D by C. Denominator of denominator, this is denominator of denominator, will go to numerator. This C will be written by the side of this denominator, right? Now tell me, how can I write this? This is 1 by root 2 multiplied by root 3 divided by 2 plus root 3. So that is 2 plus 2 root 3, right? I can write like this. Let us simplify further. See this. Clearly, this is an irrational number, denominator, right? An irrational number. Shall we leave it like this? No. See, if we can simplify the denominator further so that the denominator is not at all an irrational number, you are supposed to do that. So let us try to simplify further so that the denominator becomes a rational number. What shall we do? See, this is of the form root of something. Let us say this is of the form root A. I am thinking, how can I make this part of the denominator a rational number? I know root A multiplied by root A is A. Is it not? Yes, root 3 multiplied by root 3 will be 3. Root 5 multiplied by root 5 will be 5. Is it not? that is root 5 whole square, root 3 whole square, that is 3 root, and in the same way this is root a whole square, that is a. Is it not? So I have got an idea. If I can have root 2 here multiplying this root 2, I can make it 2. Root 2 multiplied by root 2 can be written as root 2 whole square, so that is 2. So to have it, I am doing like this. 1 by root 2 is already there. I am multiplying and dividing by root 2, so that no change will be there. But my expected result I can get. That is, now see the denominator, this part, root 2 multiplied by root 2 I have. I can replace that by 2. That's why I have multiplied and divided by root 2. Multiplied by, of course this is root 3 divided by, see this is 2 common. I can take 2 common out of these two terms itself. Of course I am taking it now. 2 plus, this is root 3 plus 1, right? 2 plus 1 plus root 3, I am writing it as root 3 plus 1. You will see why I have interchanged 1 and root 3, the next step. Now how can I write this? Of course root 2 I am writing as it is, divided by root 2 into root 2, of course I am writing it as 2, multiplied by, this is root 3 upon 2 multiplied by root 3 plus 1 is there. See, what shall we do now to simplify further? Think. See this. Now this part is an irrational number. I want to see this part as a rational number. So I want to rationalize the denominator. That is, I want to rationalize this part. This is of the form root a plus root b, is not? Because I can see 1 as root 1 also. This is of the form root a plus root b. If I can multiply this with this expression root a minus root b, this will be of the form a plus b into a minus b, a square minus b square. So this is root a whole square minus root b whole square. Root a whole square is a minus this is b. Now irrational part is not there. We have made it a rational number, right? Squares are eliminated now. Square roots are eliminated. That is how we shall think now. Now I am, to get this in that form, I am multiplying and dividing by the term root 3 minus 1. What is that? I am multiplying and dividing by the term root 3 minus 1. This is called rationalizing the denominator, because the denominator is an irrational number which is of the form root a plus root b. I am multiplying and dividing by the term of the form root a minus root b. That's what I have done here. So that now the denominator becomes, see this. This is, or you can think it like this also, a plus b into a minus b, a square minus b square. Now see this. Root 2 into root 3, of course that can be written as root 6. Can you see that? Root 2 multiplied by root 3 is root of 2 into 3. We can write like this. That is root 6, right? So this is root 6 upon 2 multiplied by 2 is 4 multiplied by, this is a plus b into a minus b, a square minus b square. So root 3 whole square, that is 3, minus 1 square is 1. So this part became this one. Now this part is remaining here. This is root 3 minus 1. Yes. Now see the denominator. Denominator has become rational number now. You don't have a rational number. So you have rationalized this complete denominator in this way. That's what you have done. Of course, let us simplify further. What is the denominator here? 3 minus 1 is 2. 2 multiplied by 4 is 8. This is root 6 multiplied by root 3 minus 1. We can leave it like this, right? can leave it like this, or that's all. So this is the answer for part 3. Next, let us see part 4. Part 4. This is sine 30 degrees plus tan 45 degrees minus cosecant 60 degrees upon secant 30 degrees plus cos 60 degrees plus cot 45 degrees. This is given. You are supposed to find the value of this expression. Yes, see question number fourth part of question number 1. This is sine 30 degrees plus tan 45 degrees minus cosecant 60 degrees divided by upon secant 30 degrees plus cos 30 degrees 60 degrees plus cot 45 degrees. Let us substitute the values in simplify this. What is sine 30? From table sine 30 degrees is 1 by 2. Tan 45 degrees is 1. Cosecant 60 degrees. How will you remember this? I have remembered it as 1 by sine 60 degrees. Sine 60 degrees is root 3 by 2. Reciprocal of this is 2 by root 3 upon secant 30 degrees. That is reciprocal of cos 30 degrees. Cos 30 degrees I have remembered as sine 60. That is root 3 by 2. Reciprocal of that is 2 by root 3 plus cos 60, that is sine 30. 1 by 2. Cot 45 degrees and tan 45 degrees we know. We have remembered tan 45 degrees, cot 45 degrees both are equal to 1. So this is 1. Are they equal numerator and denominator? They are not equal. This is minus 2 by root 3. This is plus 2 by root 3. This part is same of course. So let us simplify further. 1 by 2 plus 1 by 2 is of course 3 by 2, right? Minus 2 by root 3 upon 2 by root 3 plus 1 by 2 plus 1 is again 3 by 2. So I will write it like this. 3 by 2 plus 2 by root 3. Looking good. Right, okay. Now this is of the form, see, A minus B. This is of the form A plus B. Because I can see that these two are equal, these two are equal. So what shall we do? Let us multiply and divide by the term A minus B. Yes, that is, I am multiplying and dividing by the term 3 by 2 minus 2 by root 3. See, because I am multiplying and dividing with the same term, value of this will not change, but I will get an advantage. What is that advantage? Because this is of the form A plus B multiplied by A minus B, that is A square minus B square. So now denominator becomes 3 by 2 whole square minus 2 by root 3 whole square. So that because root 3 part, that is irrational part, will get eliminated. Is it not? Yes, of course, numerator is 3 by 2 minus 2 by root 3 whole square. Yes, how about the denominator now? Tell me. This is 3 by 2 whole square is 9 by 4 minus, this is 2 square by root 3 whole square. 2 square is 4, root 3 whole square is 3. Now denominator became a rational number. Irrational part is eliminated. Yes. Yes, of course, let us simplify further. See this. This is of the form A minus B whole square. That is A square plus B square minus 2AB. Right? A square is 3 by 2 whole square. That is, can I write directly? Yes, 3 by 2 whole square is 9 by 4. A square plus B square I am writing. B square is 2 by root 3 whole square. That is 2 square by root 3 whole square. 2 square is 4 upon root 3 whole square is 3. A square plus B square minus 2AB part I am writing in the last, right? At the end. Minus 2AB, that is 2 multiplied by 3 by 2 multiplied by 2 by root 3. Yes. Let us simplify further. 2 got cancelled. How about this one? What is the LCM here? This is 12. 9 3s are 27 plus 4 4s are 16. 27 plus 16, that is 43, right? Minus, this is, see, can you observe any relation between this numerator and denominator? Yes, this is 3, this is root 3. Is there any relation? Yes, 3 is nothing but square of root 3, right? Root 3 multiplied by root 3, if I have, I can write it as 3. Or if I have 3, I can write that as root 3 multiplied by root 3. As if I require, I can do right like that, right? See here in this case, because I have root 3 in the denominator, now I am looking at 3 as root 3 multiplied by root 3. So can I cancel one root 3 here? Yes. So what will be remaining? Root 3 here. Root 3 multiplied by 2. That will be 2 multiplied by root 3. Yes. By upon, what is the denominator here? Yes, 12. Numerator 27 minus 16. That is 11, right? Yes. Let us simplify further. Yes, this is 1, right? What is the LCM here? 12 and 1, 12. This is 43 minus 12 into 2 root 3. 12 2s are 24, right? 24 root 3 divided by 11 by 12. Of course, denominator got cancelled. So what is remaining? 43 minus 24 root 3 upon 11 is remaining, right? This is the answer for that question. This is part for part 4. Let us see next fifth part. Yes. Yes, what is part 5? 5 multiplied by cos square 60 degrees plus 4 multiplied by secant square 30 degrees minus tan 45 degrees upon sin square 30 degrees plus cos square 30 degrees. This is the question below. Yes, let us substitute corresponding values and simplify. This is 5 multiplied by cos square 60 degrees is cos 60 degrees whole square. What is cos 60 degrees from table? Sin 30 degrees, that is 1 by 2 whole square plus 4 multiplied by secant 30 degrees whole square is this. That is reciprocal of cos 30. Cos 30 degrees is sin 60 degrees, that is root 3 by 2. Root 3 by 2 whole square reciprocal, that is 2 by root 3 whole square. Minus tan 45 degrees and cot 45 degrees are equal to 1, right? 1 upon sin 30 degrees whole square is this. Sin 30 degrees is 1 by 2 plus cos 30 degrees is sin 60, that is root 3 by 2 whole square is there. Yes, let us simplify further. This is 5 multiplied by 1 by 2 square is 1 by 4 minus 4 multiplied by 2 square by root 3 whole square. 2 square is 4, root 3 whole square is 3 minus 1 upon 1 by 2 whole square is 1 by 4 plus this is root 3 whole square upon 2 square. Root 3 whole square is 3 upon 2 square is 4. Let us simplify further. This is 5 by 4 minus 4 multiplied by 4 is 16 by 3 minus 1 upon, what is this? LCM is 4. This numerator is 1 plus 3. Now 1 plus 3 is 4, so 4 by 4, this is of course 1. However, the numerator, let us take LCM. What is LCM here? You can imagine 1 here, right? 4, 3, 1. LCM is 4 multiplied by 3, that is 12. Now this one, 5 multiplied by 3, 15 minus 4 multiplied by 16, 64 minus 1 multiplied by 12, 12. This is 1, right? So what is remaining here? We got wrong. Yes, this is negative. No, somewhere we have gone wrong. Yes, here I think this is plus. This is plus, right? This is plus. So this is plus. So what is remaining here? Denominator is 12. Our numerator 64 plus 15 minus 12. 15 minus 12 is 3. 3 plus 64 is 67. So 67 upon 12 is the answer, right? Yes, this is fifth part of question number 1. So question number 1 is over. Let us see question number 2. Question number 2. Choose the correct option and justify your choice. That is the question given. It has got 4 parts, right? Let us see first part. 2 tan 30 degrees upon 1 plus tan square 30 degrees is dash. Options. First option sin 60 degrees. B is cos 60 degrees. Option C tan 60 degrees. Option D sin 30 degrees. That is the question given, right? Yes. Directly let us substitute the values of trigonometric ratios from the table. Yes. 2 multiplied by tan 30 degrees is from table 1 by root 3 upon 1 plus tan 30 degrees whole square is this, right? That is 1 by root 3 whole square. This is 2 by root 3 upon 1 plus, this is 1 square by root 3 whole square. 1 square is 1, root 3 whole square is 3. So this is 2 by root 3 upon 4 by 3, right? And this LCM is 3. This is 3, this is 1, 3 plus 1 is 4, right? So how shall we write? This is of the form A by B whole by C by D. So can I write like this? A by B multiplied by D by C, right? D by C. So this is 2 by root 3 multiplied by 3 by 4. This is 3 by 4. Let us simplify further. Yes, 2 times, right? Again 3 root 3 is there. Earlier we have discussed it. So how shall we proceed? This is an irrational number. I don't want this denominator to be an irrational number. I can rationalize. So how shall we proceed? So multiplying and dividing by root 3. Or I am able to see 3 as root 3 multiplied by root 3. So 2 multiplied by root 3 multiplied by root 3 upon root 3 multiplied by 4. This is what I am able to see. 1 root 3 I can cancel. 2 times. So this is root 3 will be remaining in the numerator and denominator 2 is remaining. So this is root 3 by 2. Yes, let us see the options. Which option is equal to root 3 by 2? First option sin 60 degrees, root 3 by 2? Yes. Remaining, of course, they are not. What are the options? The option here, sin 60 is root 3 by 2. Of course, this is not root 3 by 2, 1 by 2, right? This is root 3, this is 1 by 2. So your answer is option A. Yes, next. Second part. Second part. What is that? 2 multiplied by tan 45 degrees upon 1 plus tan square 45 degrees is dash. What are the options? A. Option A is sin 90 degrees. Option B is 1. Option C is sine 45 degrees. Option D is 0. Yes. Option D is 0. This is the question given, right? Let us substitute the values and simplify from the table. 2 multiplied by tan 45 degrees from table is 1 upon 1 plus, this is tan square 45 degrees. That is tan 45 degrees whole square. Tan 45 degrees is 1, so this is 1 square. So 2 multiplied by 1 is 2. 1 square is 1. 1 plus 1 is 2. 2 by 2. That is of course equal to 1. 1 is the answer, right? Which option is correct? Yes. Yes, of course. What about option 1? Option A, sine 90 degrees. What is sine 90 degrees? 1. Of course, you can observe 0 sine 45 degrees. Of course, this is sine 45 degrees 1 by root 2. This is 1. This is sine 90 degrees is also 1. Your answer is also 1. So, either which option is correct? A, it may be A or B. Both are giving you 1, right? Sine 90 degrees is 1. Option B is also 1. So which is appropriate? Is it wrong then? Yes. Think like this. See, here you are supposed to know one point. Of course, while discussing basics, you might have, of course, by learning basics, you might have encountered, you might have come across this point. See, 30 degrees, 45 degrees and 60 degrees, we have derived the values. We have got some procedures. While deriving the values of 0 degrees and 90 degrees for sine theta, cos theta and tan theta, we have followed a method. Do you remember that? See this. Yes. As the hypotenuse or this opposite side, that is perpendicular, is decreasing, right, gradually. At one point, let us say perpendicular becomes 0, then hypotenuse coincides with adjacent side, that is base. In that case, sine theta becomes, sine theta is opposite by hypotenuse, right? If opposite side becomes 0, that is so on, so on, so on, so on. If it is 0, then adjacent side and hypotenuse are of equal length, right? Opposite side is 0. What is sine theta? Opposite by hypotenuse, that is perpendicular by hypotenuse, that is 0 by something is 0. So sine 0 degrees is 0. However, cos 0 degrees, adjacent side of hypotenuse. Adjacent side is, of course, base and hypotenuse are equal now in that case. So you get this by this, that is equal, because they are equal, ratio is 1. And tan theta, of course, we know that opposite side by adjacent side, that is tan, right? Sorry, sine theta by cos theta, that is 0 by 1, or opposite by adjacent. In this, that way also you can think. Opposite is 0 by something is 0, of course, tan 0 degree is 0, right? But in this case, see, actually, if 0 degrees is the angle, do you see any right angle triangle at all? Tell me. No, not at all. You don't have a right angle triangle at all. Is it not? That is a hypothetical case. That is not practically possible. You cannot have a right angle triangle for the angle to be 0 degrees, right? Yes. What you have got is what you have thought is correct. Then what we have considered is these two are defined. See, we have considered them to be definitions. Let us define sine 0 degrees as 0. Let us define cos 0 degrees as 1. That's how we have considered. So by definition itself, sine 0 degrees is 0. But if you are asked to show that in a right angle triangle, you cannot show, right? Cos 0 degrees is 1. They are defined as like that. Of course, obviously tan 0 degrees is 1. That will give you remaining ones. Of course, cot is cos by sine, of course 1 by 0, because denominator is 0, that is not defined, and so on. In the same way, for 90 degrees also, Yes, sine 90 degrees is defined as 1. Cos 90 degrees is defined as 0. They are defined like that. Definition itself is that. Is it not? Now tell me, of course, for all theoretical purposes, we are considering them sine 0 as 0 degrees, cos 0 degrees is 1, and so on, for all theoretical purposes. Now in this context, see this. You have got the answer to be 1, but in the options there are two ones. Option A is 1, option B is 1. Option B is directly 1, but option A is giving us sine 90 degrees. Tell me which answer will be more appropriate now. You know that this expression is 1, of course. Directly B is directly 1, but this one, is it exactly 1? That is almost 1. Yes, theoretically we are taking that to be 1. So of these two, this will be more appropriate, this option, right? Because you have got the question like that. In this context, you can say that this is more appropriate, because A, of course, because we even though we are considering that sine 90 degrees as 1, theoretically that is equal to 1, because in this context you are in a position to differentiate between these two. You will mark option B as answer. That will be more appropriate, right? That is second part, right? Next, third part. Third part is sine 2a is equal to 2 sine a is true. That's what he has given. When a is equal to dash. First, option A is 0 degrees, option B 30 degrees, option C 45 degrees, option D 60 degrees. That is the question. Yes, let us simplify. He is saying this is true. Let us verify. He is giving in the place of A, you can substitute the given angles and see, verify. Yes, option A. What is left hand side part? Sine 2a, 0 degrees. If you substitute in the place of A, this is equal to 2 times of sine of 0 degrees, right? Is it correct? Sine 2 multiplied by 0 degrees is 0 degrees. Sine 0, of course, sine 0 degrees is equal to 2 times multiplied by sine 0 degrees. Sine 0 is 0. 2 times of sine 0 is, again this one, 0 is equal to 0. This is true, right? True. That's all. Need not go for remaining ones, right? So your answer is option A. Let us see next question number, or part 4 of question number 2. Part 4. 2 tan 30 degrees upon 1 minus tan square 30 degrees is dash. Option A cos 60 degrees, option B sin 60 degrees, option C tan 60 degrees, and option D sin 30 degrees. Yes, this is the question given. Let us simplify. Substitute the values from table and simplify. Yes, 2 times of tan 30 degrees is 1 by root 3 upon 1 minus tan square 30 degrees. That is tan 30 degrees whole square, right? Yes, this is 2 by root 3 upon 1 minus, this is 1 square by root 3 whole square. 1 square is 1, root 3 whole square is 3. So this is 2 by root 3 upon 1 minus 1 by 3 is, of course, 2 by 3. Right? What will you do now? This is of the form a by b whole by c by d. So what will you write? A by b multiplied by d by c. So this is 2 by root 3 multiplied by 3 by 2, you write. Yes, 2 cancel. Yes, you can cancel. This is 3 root 3. Yes, 3 by root 3 is root 3. We have done it twice, 2 times already in the earlier questions. So this is root 3. Root 3 is the answer for this question. Yes, which option will be appropriate now? First option A is cos 60 degrees, that is sin 30, 1 by 2. Option B, sin 60 degrees, that is root 3 by 2. Option C is tan 60 degrees is root 3. Option D, sin 30 degrees is 1 by 2. Where have you gone wrong? This is 1 by root 3, 1 by root 3 whole square, 2 by 3. Correct. Yes, cos 60, 1 by 2 sin 60, which by tan 60, root 3. Yes, of course. So this is, so your answer is option C. Next, question number 3. Question number 3. What is given? If tan A plus B is equal to root 3 and tan A minus B is equal to 1 by root 3, where 0 degrees is less than A plus B is less than or equal to 90 degrees and A greater than B, find A and B. That is the question. Find A and B. So A and B are angles. Let us see. See, from table, of course, we know the values of 6 trigonometric ratios for specified angles. Of course, from table, of course, I remember tan values also, because many questions we will come across tan values also for these ratios. So tan remembered as tan 0 degrees 0, tan 30 degrees 1 by root 3, this is tan 45 degrees 1, tan 60 degrees is root 3, tan 90 degrees not defined. So I am seeing this tan of something is root 3. From table, for tan, root 3 is at 60 degrees, right? Tan 60 degrees is giving me root 3. So from this, what can I write? Tan A plus B is equal to root 3. So A plus B is equal to angle 60 degrees, right? Let us say this is relation 1. See, just be careful here, because you are just in class 10. You are not expected much subject. Anyway, questions also will be framed like this. See, there is no controversy. That is, if in future classes you will see, if you see tan of A plus B is equal to root 3, you cannot write A plus B as 60 degrees directly. How there are infinite possibilities are there for this. You cannot say specifically 60 degrees. Because to eliminate that confusion, he has mentioned in the question itself, A plus B angle, A plus angle B sum is between 0 degrees and 90 degrees. That is an acute angle, right? So definitely you can use this table and you can directly write the angle to be 60 degrees, only because for tan between 0 and, of course, if you consider angles between 0 and 90 degrees, there will be corresponding values from 0 to infinity. 1 relation also only will be there. So obviously for root 3, only 60 degrees angle is appropriate. So you can directly write 60 degrees in the place of A plus B. In the same way, see, tan A minus B is given as 1 by 2. Yes, same logic. A is greater than B, of course. So A minus B is a positive value, which is an acute angle again, because sum of the two angles is an acute angle. Obviously, difference also will be less than 90 degrees only. Yes, 1 by root 3. Tan which degrees is 1 by root 3? 30 degrees, right? 30 degrees. So A minus B angle is 30 degrees. Let us say this is relation 2. I have got now two unknowns A and B and two equations in those two unknowns. Can I solve like them or not? Yes, I can solve these two equations. I can find the values of A and B. Yes, is it easy? Yes, add these two. 1 plus 2. 1 plus 2. will give you how much? Plus b minus b, that cancelled. A plus a is 2a. 2a is equal to how much? 60 degrees plus 30 degrees, 90 degrees. So what is a? 45 degrees. So how about b? You take any one relation and substitute the value of a, you will get the value of, or you take one relation, first relation from 1. A plus b is 60 degrees. A is 45 degrees plus b is, of course, is equal to 60 degrees. So b is 60 degrees minus 45 degrees on transposing. So it will give you 15 degrees as the value of b. Right? So 45 degrees and 15 degrees are the values of the angle C. And this is question number 3. Let us see next question. Question number 4. State whether the following are true or false. Justify your answer. That is the question. It has got, of course, 5 parts. Let us see first part. Sine of a plus b is equal to sine a plus sine b. That is given. This is an equation, right? It has got left hand side part and right hand side part. However, a and b, they are angles. Sine of a plus b is the value of trigonometric ratio. Sine a is the trigonometric ratio, and sine b is the trigonometric ratio. We are supposed to decide whether this is correct or not. Has he mentioned anything about angles a and b? No, nothing has been mentioned. So angle A and angle B can be anything, right? 1 degree, 2 degree, 3 degrees, 4 degrees, 1.5 degrees, 1.7 degrees, and so on. Root 2 degrees, root 3 degrees, infinite possibilities. Is it not? Yes. Can you verify the equation for all those values? It's not possible, right? That means if you substitute values in the place of A and B, left hand side part and right hand side part should give you same for all values of A and B. Then you can say that these two parts are equal, so this holds good. This equation is true. But there are infinite possibilities for A and B. So you cannot do like in that method, right? By verification method. But then why he has given this question? What may be the possibility? Yes, one more possibility is there. He has asked you to find out whether the relation is true or false. See, if this relation is true, it is impossible for you to show that, prove that this is true just by verification method. So maybe this relation is false. Okay, if the relation is false, let us say, in which case, of course, how can you show that this is false? See, in one particular case, if we can show that this is false, you can say that this does not hold good, right? This relation is false, you can say. Yes. So for that, you can give some A and B, which will give you different values for left hand side and right hand side. That's all. Of course, we know values of trigonometric ratios for specific angles from the table. Let us consider any two angles and verify. Let us say let A is equal to 30 degrees and B is equal to 60 degrees. Why these two? You need not take 0 degrees and 30 degrees, 0 degrees and 45 degrees, 0 degrees and 60 degrees, 30 degrees and 45 degrees, 30 degrees and 90 degrees, and so on. Any combination you can consider. But let us, of course, we have considered one. If it, let us substitute and simplify. Let us simplify. If it gives, let us say, left hand side part and right hand side part as equal, can you say that? What can you say about that? Can you conclude that this given equation is true? No, we cannot conclude. Then we will have to check another combination of A and B. If that also gives you, again another combination. If that also gives you true, that is left hand side part, right hand parts are same, then another combination, that's all, that is and so on. Of course, let us see if it is giving you left hand side part and right hand side part are not equal, then you can conclude that this relation is false. Yes, let us verify first. Left hand side part, that is LHS, is sine of a plus b, sine a plus b, that is equal to sine 30 degrees plus 60 degrees, that is sine 90 degrees. What is the value of sine 90 degrees? We know, yes, from table again, sine 90 degrees is 1. So left hand side part is 1. How about right hand side part? Sine A plus sine B, that is sine A is 30 degrees plus sine B is 60 degrees. From table again, sine 30 degrees is 1 by 2, sine 60 degrees is root 3 by 2. Yes, this is 1 plus root 3 by 2 is the answer for right hand side part, simplified value for right hand side part. Now, are they equal? No. Left hand side part is not equal to right hand side part. So, given equation is not true or false. True or false is asked, right? It's false. Right? False, yes. Justify. How do you justify? Yes, for the given equation to be true, it has to be true for all values of a and b. But in this particular case, this is giving you different values for left hand side and right hand side parts. So we cannot say that the given relation is true. So that is false. Yes, that is the justification. Yes, let us see next question, next part. Next part, that is second part. The value of sine theta increases as theta increases. That is given. Yes, sine theta. See, as theta increases from 0 to 90 degrees, we know some values, right, in the table. How about sine theta? Earlier also we have discussed 0, 1 by 2, 1 by root 2, root 3 by 2, 1 increasing, right? So this is true. How about cos? Decreasing, right? How about tan? Increasing. Anyway, next, third part. The value of cos theta increases as theta increases. Yes, just now you have seen, as theta increases, cos theta decreases. So this is false. False. Fourth part. Sin theta is equal to cos theta for all values of theta. That's what he is giving. Is it true? No. This is sin theta values. These are values of cos theta. Are they equal? No. False. Question number part 5. Cot A is not defined for A is equal to 0. That is cot of 0 degrees, right? Cot of 0 degrees is not defined. That's what he is saying. Is it not? Yes, we know cot 0 degrees is reciprocal of tan 0 or cos 0 by sin 0. Cot 0 degrees is cos 0 degrees by sin 0 degrees, right? Cot is cos by sin, right? Cos 0 degrees we have remembered as 1, sin 0 degrees is 0, denominator is 0. So this is not defined, right? Not defined. So whatever he has said is correct. So your answer is true. At 0 degrees, not defined, right? Yes. So your answer is true. So with this we conclude question number 4 also. This exercise is over, and of course I am reminding you, please if you have not subscribed so far to my channel, please subscribe. If you like the video, you do like and do some comment also, and if you find it useful, please share this video to your friends also, so that they also will benefit from this, right? Thank you.